So we're now going to shift our focus from savings to loans. Now, there are different types of loans that exist out there. I mean, obviously simple interest loans and compound interest loans. But we're going to focus today on compound interest loans, specifically looking at a type of loan that's called a reducing balance loan, or it can be called other things as well. It's the most common type of loan out there. Principal and interest loan is one of the words I commonly hear it called as. But basically what we're effectively trying to do is reduce the balance of the loan. So take out a lump of some money at the start and reduce the balance of the loan over the period of time. So hence paying off the principal as well as the interest at the same time. Hence the reason principal and interest loan comes about. So a lot of this we're going to be doing with our graphics calculator. Now it's the same TMV solver that I showed in a previous video, so go back to that if you want to have a look at that. However, there are some different things, like different inputs that we need to be very aware of, but also when we look at questions like question B here, hence calculate the total interest charged on the loan, that is a little bit different how we got about, calculating that, and it can actually become quite complex depending on how complex the loan itself actually is. And yeah, we'll get to that as we go. So in front of us here, we've got Robert takes out a $15,000 loan to be repaid over 5 years at an 8.5% per annum, interest compounded monthly. So first thing is we need to calculate the monthly repayments of the loan. This is a very common thing that you need to be able to do, because you have to be able to calculate how much interest you're going to be charged over the period of the loan, or how much you're going to have to pay in total over the loan, or many other different things. It all comes back to, first of all, looking at what your regular repayments are actually going to be. And this is something that's even important when you're working out, can you actually afford this loan? So the first thing that we're doing here is going into our graphics calculator, but let's first record what we're going to input. But essentially going through these. So N here is how many times it's going to compound. So it's going to be 5 years and it's compounding monthly. So 5 times 12. Interest rate here is 8.5%. Our present value here. Now this is something that's first of all a big note here. The present value in savings, because we were initially giving money to the bank, was always a negative. In loans, you're actually getting the money from the bank at the start. So the present value at the start is actually a positive when we go to put it into the bank, because it's money we're getting from the bank. So it's positive 15,000 here. And then the PMT, that's what we're actually calculating. The future value, well, we're assuming that we're going to have to pay it off at the end of it. So the future value here is going to be 0. The PY, the payments per term, we're assuming it is monthly repayments, so it's 12. And the CY is compounding monthly, so also 12. Now, essentially, we just need to plug these values into our calculator. And when we do so, it gives us negative 300, and this is approximately $7.75. Now, because it's a negative here, we've got to be thinking about this. It's going to be negative because we're giving that money to the bank on a regular basis, but I like to interpret it when it's negative. So therefore, Robert's monthly repayments are approx $307.75. So I just like that general rule of thumb whenever this is a negative, that we, interpret what that actually represents in context of the question. So now let's look at calculating the total interest of the loan. Now, essentially, to ever calculate total interest, there's two things that we need, two bits of information. Interest. The first bit of information that we need is how much have we repaid the bank in total. So it's total repayments. Could also be referred to as total cost. How much we've actually given the bank back for this loan in total. Subtract away the original loan. Now, if we think about it, the difference between these, how much we've actually given the bank and how much we got from the bank to begin with, is going to be how much extra we've had to pay in total for the loan. And that's going to be the total interest that we've actually paid here. So essentially, total repayments, well, we're paying $307, well, approximately, so this is approximately $307.75 each repayment. And we did that for 5 years. And we repaid it monthly, so 12 times per year. All right. Now, you don't have to bracket this, but I tend to like the rule of bracketing it because as things become more complex, it can be very useful to actually bracket the total repayments and then subtract away the loan here, which was originally $15,000. So therefore, our total interest it's going to be approximately equal to, let's whack this in the calculator. So 307.75 by 5 by 12. Subtract away the 15 grand. So in total, we've had to pay $3,465 in interest. Now, so that's how you essentially calculate the total interest of something. It's total repayments, subtract away the original loan. Like I said, it can become quite complex as the complexity of loans increases, but we'll get to that in future videos. So one last thing we'll look at for this video is how do we actually calculate the outstanding balance at any point in time of the loan. It's a common thing that we might need to do because things might change throughout the loan. You know, an interest rate might change, or you might decide to make extra repayments or change the repayments that you're making, or you could do a whole range of different things here. You might even refinance the loan. So being able to work out the outstanding balance at any given point in time is something that's really, really useful. So to do that, we're essentially going through the TMV solver again. So the end here is the thing that's changed. So we've got 1 year's worth of repayments times 12, so it's just going to be 12 repayments. The interest rate is still going to be the same, so it's 8.5%. The present value, that's how much you had at the start, so you're taking it out, so it's positive. The PMT, we now know what that is, so it's approximately 300, hang on, it's negative here. Let me just quickly make that negative. So getting the signs correct is really, really important. Otherwise, you can get some really wacky numbers. So negative $307.75. Future value, that's what we're actually calculating. The P, Y, and CY are both 12 here. So now our future value is going to be approximately, so 12, it's going to be approximately negative $12,485.56. Because it's negative, once again, we should interpret it. So therefore, the outstanding balance after 1 year is approx $12,485.56. So that covers a couple of real key skills, or a few real key skills that we need when we're dealing with reducing balance loans. We're often needing to calculate the monthly repayments, which we can see in part A. Once we've got the monthly repayments, we're often looking at how much extra over and above it's going to cost us to be able to repay that loan, which is known as the total interest. So, you know, you need to calculate your total repayments that you're going to make throughout the loan and subtract away the original loan to get that. And often we're also looking at how do we actually calculate the outstanding balance at periods of times, particularly when the loan actually changes at a certain interval, which we'll look at as we continue with different types of loans.